function of a random variable. Okay. First, we find the expected value of a function. And you know expected value for discrete random variable is let's suppose function is fx. Okay, not fx. Let's suppose this is gx. Then expected value of gx will be what? Summation of gx into px. For continuous, expected value of function is what? Gx into fx. Okay. Fx is what? PDF. And gx is any function. So you can say gx is any function and fx is PDF. Probability density function. Okay.
GX what? I'm sorry.
Gx is any type of function, any function. Let's suppose gx.
Okay.
Yes, it is given ex square 1 upon x square, any function. Now you are going to find the function of a random variable, not a any number. Okay.
Function. Okay.
Yes.
Two functions we have GX and PX.
Yes. No, px is the probability, fx is the PDF.
Okay.
You know px is probability for discrete random variable and this is PDF for continuous random variable. Gx is any other function.
Okay.
Okay.
Yeah. Okay. If it's a continuous, so integration from minus infinity to infinity.
Yes.
GX. Okay.
Yeah, earlier you have learned what? E of x. Suppose gx is x. Then you put here x into px, right? You remember?
Right. Yes.
For discrete random variable. For continuous, let's suppose gx is x. You write x into fx, right?
Right. Exactly. Yeah.
Yes. So here x is replaced with gx.
I see.
Right? Now we consider a function of a random variable. Earlier we have seen that random of expected value of a random variable x. Now we are going to learn expected value of a function gx. Okay, function may be anything.
Makes sense.
Yeah. Okay.
Yes.
Let's suppose here you can see consider a random variable x with the density this. What is the expected value of ex? See, what is expected value of ex, right? So you can write here what? Expected value of ex, right? You can write in this way. Okay. Yeah. And this is what? This is continuous random variable. Let's suppose this is gx. Gx is what? Ex. And you know for a continuous random variable, expected value of function is ex into fx. Why ex? Because this is gx, right?
Yes.
and limit goes from
And-
yes,
Do we have the fx? Yeah, we have fx.
yes, yeah, we have fx here, and fx goes from 0 to 3 only. For rest interval, it is 0. Okay.
Yeah.
You are not finding the expected value of x. You are finding expected value of ex. So when you replace x with ex, you will get like this, right? Okay.
Yeah.
Okay. Now we integrate on by integration by part. Okay. What is the value of fx? 1 by 9 x square. One by 9 is constant. Use UV rule, right? U integration of v. This is called integration by part. Wow.
Yeah.
U integration of ex minus differentiation of u integration of ex dx, right?
Right.
Integration of ex is ex. Derivation of x square is 2x. Integration of ex is ex dx. Again, you can see here you have to apply one more time UV rule, right?
Yeah. One integration.
Yes. So I solve in bracket u integration of v minus derivation of u integration of v whole integration, right?
Yeah.
1 by 9 minus 2x integration of ex is ex minus minus plus 2 derivation of x is 1 x square ex minus and limit goes from 0 to 3, right?
Yeah.
When you put 3, it becomes 3 square e3, 2 into e3, e3. Now put 0. When you put 0, this part will be 0 because 0 into anything is 0. This
Right.
is also 0. 2 raised to
0.
0. Yes. 9 e3, 6 e3, 2 e3 minus 2. This is your final answer. Okay.
Yes. Yeah.
You can go through once. You can calculate yes, e raised to 3 from calculator.
Yeah. Let me go through the solution one more time, please.
Yes, right?
3, 1, 9. Yeah.
Okay. You can further solve. 9 minus 6 is 3, 3 plus 2 is 5. Right? This is your answer.
Mm.
Right?
Yeah.
Okay. Yes, correct answer. Okay. The average value of a function from x is equal to a to b is expected value of fx. Okay. You know, average is what? Expected value, where x is uniform random variable. You know, if
Yeah.
fx is uniform random variable, then it PDF is 1 upon b minus a. When I find the
Yes.
expected value of fx, so it becomes what? It means that you are finding e of fx. Fx is any other function. So you can write, let's suppose here, you can write what? Fx, and the PDF of fx is 1 upon b minus a, right? A to
Yeah.
b fx. This is different fx. This fx is not same as PDF. Okay. Let's suppose this is gx.
GX. Okay. Yeah,
And
that
this
makes
e
sense.
of fx is called f average. If I ask you what is the average value of function of uniform this random variable, you can say it is expected value of fx. Okay.
Okay.
Yes. And you already know how to find the area of a function. Area is what? Limit of x1 fx, right?
And
Uh,
integration of
yes.
function.
Earlier I told you. Let's see this example. Compute the average value of function. Okay. You know the average value of any function is what? 1 upon b minus a f of x dx, right? From x is equal to 1 to 3. This, right?
Yeah.
B means what? 3 and a is 1. So you will have 3 minus 1, 1 to 3. Fx is x e x square. 3 minus 1 is what? 2. E x square x dx. Now what you will do? Put x square is equal to t. So 2x dx becomes dt, right?
Mm-hmm.
X dx become dt over 2. So x dx is replaced by dt over 2. And you know the limit is also changed. Limit of x was 1 to 3. When you put here 1, 1 square is 1. When you put here 3, 3 square is 9.
Oh, now I'm a little bit confused because we have x multiplied by ax
Yes,
to the power 2.
yes.
So why we didn't like consider x and ex to the power x as two different functions and we use integration by parts?
Okay, why we are not using integration by part, right?
Yes.
Okay. F of average okay. See, use integration by part only when ex into x is given. In this case, ex square is given. So when you consider it as a t,
Okay.
right, you will get x dx.
Uh-huh.
So I told you use substitution rule only when its derivation is present in that integration, right? When you consider x square is equal to t, you will get what? 2x dx is equal to dt. So you are getting what? X dx,
Yeah.
right?
Yes.
If you get x dx, then it becomes e raised to t and x dx is replaced by dt by 2. That's it. Now you can integrate simply. No need to write integration by part.
Okay.
Okay. If it was again x ex, then use integration by part rule.
I see the difference. Yeah. Now I see.
Okay.
Thank you.
So here you are getting 1 by 2 et, limit from 1 to 3. 1 over 4. What is the value of t? Ex square, right? When you put
Yes.
3, you will get 3 square. E raised to 9, e raised to 1. This is your answer. This is the average value of function.
I see.
और इसका ड्राइंग है और वो done. You can go through one.
Yeah.
Now you will learn how to find variance. This is very, very important. Okay. This is called variance. You know what is variance? Variance is what? Standard deviation का whole square. This is standard deviation.
Variance is equal to standard deviation square.
social level. You know what is standard deviation? Any idea?
I know that there's a relationship between average and standard deviation, but I can't recall.
Okay,
What's the
see,
formula?
suppose your result is 50, let's suppose 75%. Let's suppose, okay? Okay. Can you tell me, let's suppose you have 5 subjects, and when you take average of this, you are getting 75%, right?
Yes.
Can you tell me that in each subject you are getting 75?
It's the average, right? Some of them they are less, some of them are they are higher.
Yes. It is not sure, it is not possible that in each subject you are getting 75 marks. In some subject you will get less than 75, in some subject you will get greater than 75, right?
That's correct.
But if I tell you your result is 75% with standard deviation 5, it means that your marks lies between 75 to, you can add plus and minus, so
I see.
your marks lies between 70 to 80 marks, okay,
Oh, that makes sense. Okay.
whose average is 75.
So the standard deviation. Okay.
It is not necessary
the-
that 70 from 70 you can get to 70.1, 17.9, 72.8, 77.8, 77.9. So between 70 to 80 you can get any number whose average value is 75. This is called standard deviation.
Okay, it's the distance for the different values from the average.
Yes.
So that it's, yeah, the distance 5 points plus or minus.
Yes.
Yeah. Now, thank you very much.
Yes.
Thank
So
you very much.
whenever you purchase any electrical item, let's suppose you are purchasing a cell. In cell, it is always written plus minus 0.5 volt. It means plus minus 0.5 is a standard deviation.
Standard deviation. Yeah.
It means that if the battery is taking 5 volt, it can also take extra plus 5 volt or less 5 volt. It is not guaranteed. Okay.
Right.
This is called standard deviation.
Mhm.
Now you understood?
Yes, definitely. This is the first time I know that statistically what does it mean the standard deviation.
Yes,
Thank you.
this is a significant. Now, what is the use of variance? Why we use variance?
I don't know.
Okay, because this is square of standard deviation. Let's suppose your result is 75% and your friend's result is also 75%. But I am saying this person is but I am saying that this person, let's suppose person A and this is person B. Both person are getting 75 marks. But I am saying that this person is more consistent. Why?
What do you decide?
Because when you see the variance of each person, the graph of this person is, this is graph of person A, yellow color, and the graph of person B is this. It means that the green person marks is less spread, and the marks of yellow person is higher speed. Higher speed means it has greater variance and it has lesser variance. Variance means what? Variance means this person is very close to 75 marks,
I see.
right? Green person is, let's suppose green person is taking 73, 77, 72, okay? And yellow person is also getting 75 marks, but its by is higher speed. Higher speed means its data is speeded. It is greater variance. You can see in one subject it is getting 80 marks, and in one subject it is getting 50 marks. In one subject it is getting 75. So you can see there is greater variance from 50 to 30, right?
I see.
This is 50 to 80. The more variance. Variance means the lower marks and higher marks have greater difference. This is called variance. But when you see the result of this, you can see this is very close. The middle line is called 75, right? So 75, when you see the green curve, you can see it is very close to 75, right?
Yep.
And when you see the yellow curve, you can see it is not much closer to 75. But both curve have 75 average value. So who is more consistent?
The one with the lower variance.
Yes, the lower the variance, the greater is consistency. Now you understood?
Yes.
Yes, because this person has smaller standard deviation and this person has larger standard deviation. Okay.
Yep.
Now you understood why we use variance for comparison of two data. Okay.
Yeah.
When you
Yeah.
compare
Yes.
more than two data, you can see easily who is more consistent, and you can see which data is useful, right?
Right.
And variance can be found by this formula. Okay, I see one example. Find the in statistics, only mean cannot decide the data is good or bad, right?
Mhm.
Along with mean, you have to also find a standard deviation variance. So if I say your marks is 75, it doesn't mean that you are good. If I say your marks is 75 with standard deviation 3, it means that you are very nearer to the marks, right?
Right.
But if I say your marks is 75 with standard deviation 10, it means you are not much closer to the mean, right?
Right. Yeah.
Yes,
Yeah. I see the point.
yes. If I say your marks with 75 with standard deviation 3, your friend marks is 75 with standard deviation 10. Who is more consistent? This person, right?
Yeah. Right.
So only average cannot decide who is more consistent. That's why we also find variance or standard deviation. Noted?
Yep.
Now I explain with one example. Find the variance of So we are going to find the variance of this function, and this is what, continuous function, right?
Right.
So for finding variance, first we have to find ex. You know how to find ex? Ex is what? X into fx, right?
Yes.
X into fx. Sorry, x is x. X into fx. So 2x squared. You know integration of x square is? Yes.
Yeah.
2, 2 raised to 3 minus 3. 8 minus 3 is minus 1 minus 3. 7 by 3. 14 by 3, right?
Yeah.
Okay. Now we find ex square. Okay.
Yes.
Ex square, this is a gx, this is a function. You know ex square is x square fx, right?
Yeah.
2x cube, right? So 2x cube integration is x raised to 4 over 4. 16 over 4 is 4 minus 1 by 3. 15 over 4. 30 over 4, right?
Mm-hmm.
So we have ex square and ex. Put these two value here. So formula of vx is ex square minus ex whole square, right?
Yeah.
This is ex whole square. Don't worry, don't write ex square, right?
Yeah.
So 14 over 3 is 196 over 9. 270. Right? You can calculate by calculator. 290, 270, 94. This is variance. Okay.
Yep.
Yes. If I ask what is standard deviation, then you can take root of variance. Right? So
Yeah.
what is standard deviation? Under root of Vx. Right? You will get in points.
So,
Yes.
so if I have a system that has been described as formula,
Yes.
using these rules, I can calculate the standard deviation and variance
Yes.
without the need, yeah, for data set or something.
Yes. You can find variance and standard deviation for any probability by using this formula.
Yeah.
Okay. Understood? You can go through one. Variance can be anything, but variance is always positive. This is also very important. Variance is always greater than or equal to 0. This is very, very important. Okay. Okay. Check it. मैं ले जाऊंगा आज। ए मुझे देना ये। डन। अंडरस्टूड।
Yes.
Yes. Variance can never be negative. Why? Because variance is what? Square of standard deviation. And you know, when you when you do square of anything, it is always positive. Mean can be negative, no problem. It is negative, but variance is always positive. Okay. Okay. So I am going to find the variance of this uniform distribution. Okay. What is uniform distribution?
1 over B minus A.
Yes. Fx is what? 1 over 8, right? First we see simple question. Okay. So first we find Ex. Ex is what? X into Fx from 0 to 8. So, sorry, 0 to 8. This is 8. X, Fx is what? 1 over 8. Integration of x square over 2. 64. 64, how? 8 square, right? Now we find x square. मैं सॉल्व को तैयार करना x cube over 3. 8 cube. और उसको टिफिन मत देना, मैं ले जाऊंगा. So 8 cube is what? 8 8 cancel, 3 8 square. 64 over 3, right? Now you know the formula of variance. Ex square,
Minus.
Ex whole square. Okay, you know Ex square is represented by mu, right?
Yep.
Yes. So Ex square is what? 64 over 3. Ex is what? 4 o square, right?
Yeah.
64 over 3 minus 16. When you do cross multiply, you will get 48 over 3. 16 over 3. 16 over 3 means 5.166. This is variance. Okay. It means that if mean is no. If I ask you what is standard deviation, it is under root.
Square root.
Yes.
Right.
Okay.
This is for the function over the area at the period
Yeah.
from 0 to 8, right?
Yes.
Mhm.
It means that if mean is 4, then its standard deviation will be 2.1. Okay. For this PDF. Okay. Understood?
Yes.
Go through once.
Okay, so the f of x here is 1/8.
Right? Okay, done.
Yep.
16/3. Right?
Yes.
Okay. You can see this example. Suppose x is a random variable with outcome in the range it is. What is the range of outcome? 3x square. It's very easy. Y is equal to what? You are going to find the range of y, right?
Range of what? Y, okay.
Okay, this is the range of x. So what is the range of y? Okay, very simple. You can see here. Y is equal to what? 3 upon x square. Lower range of x is 2. 3 upon 4, right?
Mm-hmm.
And upper range is 7. Okay, so lower range is 3/4 and upper range is 3/4. This is very simple, right?
I see. Yeah, compensate.
Yes. See, you are going to find the expected value of 1/w. Okay, here function is what? 1/w, and w is what? Random variable, right? W is a random variable.
Yes, sir.
So E over W, right? You know, gx is a function. Here function is what? 1/w into f of w, right? That's it. Okay, and gc is
Yeah,
0 to t. Here f of w is what? 144, right?
I see.
So whatever here it is given, always put here. If w square is given, then you can put here w square. If w cube is given, then you put w cube. Here 1 upon w is given, so you can put here 1 upon w, right?
Yeah. And this is 1/w is the gx, right?
Yes, gx. Let's suppose this is gx. Now we understood. Here any type of function is given.
Mm.
36 minus w square upon 144. dw. 1 upon 144 is constant. One 44 0 to 6 36 over w minus w, right?
Yeah.
So 36 1 upon w integration is log w, and this is w square over 2, right? You know integration of 1 upon w is what? Log w, right? Put upper limit. Now put lower limit, right?
Mm-hmm.
You know what is ln0? ln0 is does not exist.
Does not exist.
Yes, log of 0 has no any real value. So if it does not exist, you can say the whole value will not exist. Okay,
Yeah.
it means you cannot find expected value of 1 over w. Why? Because ln0 is undefined, right?
Yeah.
Yes, because let's suppose this is infinite. Infinite plus or minus anything is infinite. Infinite means does not exist, right?
Yeah.
Yes. Okay. You can see this question. T is a random variable with density function this, right? T is a random variable ft. मैं उठने वाला ही हूँ. You have to find expected value of t cube. Here gx is what? T cube. So you can put here t cube.
Mm-hmm.
Right? T cube basically what? Small t. Here it is given. Big T, small t, right?
So big T and small T, two different variables.
Uh, Actually, capital T represents random variable, but its actual value is small t.
I see.
Here you can see, here capital T is random variable and small t is the representation. Okay.
Yeah.
So 2 over 3, 3 plus half, 7 by 2, right? Why? Because t raised to 3 and this is half. 9 by 2 upon 9 by 2. So you can see into 2. When you put t is equal to 1, you will get 9 and 0. Okay. So 4 upon 27 is the answer. Right?
Yep.
Yes. But if I ask you what is the value of ET, ET means basically I am asking what is the mean of this variable. Right? You understood how I solve this? You can go through once.
ET what again? Sorry.
ET is expected value. You can see t into f of t. Okay.
Okay.
So only multiply here t, not tq. Why? Because when tq is given, multiply with tq, right?
Mm,
And this is called mean. Noted?
yep.
Okay. If x is a random variable, then ex is called mean. Ex square, ex cube, ex4, and let's suppose egx is any function. Okay. So first, this is called first moment. First moment is called mean. This is its name is second moment. This is third moment. Okay. This is fourth moment. And this is moment of a function gx. Moment of function gx. Or you can say what? Expected value of,
G of x.
yes, g of x. You can also say expected value of x4. Okay.
Yes.
Expected value of x cube, expected value of x square, expected value of x. Expected value of x is also called first moment or mean. This is called second moment. And for variance, these two things are important, right?
Right.
Ex square minus ex whole square. It means second moment and first moment whole square. Okay.
I see.
Yes.
Yep.
Understood?
Yep.
Yes. So this chapter is also finished, right? Very
Yeah.
easy chapter was there, right? Next
Yep.
time we discuss series and uh, sequence. These are very important for
Understood.
finding the larger value. You have heard this name: series, sequence, power series, Taylor series,
Yep. Yeah.
right?
Time series analysis.
Yes. Then we will start three-dimensional coordinate system, limit and continuity. This is not basic limit and continuity. This is limit and continuity for two variable x and y.
I see.
Earlier you have learned limit and continuity for one variable f of x only. Okay.
Right. Right.
So next time means from Monday, right?
Yep.
So from Monday we start series and sequence.